Welcome back, everybody. All right, it's time. It's time to start learning about the IP routing process. We need to understand how we get from this PC to this PC, or from this PC to this PC. It really doesn't matter if it's 2 PCs or 2,000 PCs. The process is still the same. Obviously, what makes the difference is the media that the information is being carried on, right? If it's an Ethernet media, if it's a serial media, if it's wireless media. But again, don't burden your brain with all this. Remember, we're doing this for a CCNA certification. So what I'm about to explain, is the routing process, which is the routing process regardless of where you're doing it on live routers or the packet tracer, wherever you do it. Routing is routing, okay? And the process still remains the same. Okay, so what happens? PC0 wants to ping PC1. So the first thing PC0 has to do is say, hey, this packet is not part of my network. So I must then send it to the gateway. So it's going to send it, if this is your first time, it's going to send an ARP request because it's Ethernet, and Ethernet and IP version 4, ARP still exists. So it sends an ARP request to the default gateway, meaning to your F00. The F00 gets that request and says, oh yes, this is me. Here is my MAC address. Right? So once it gets the MAC address, it sends the information back down to complete that frame. So now you have a source MAC address, destination MAC address, source IP address, and destination IP address, plus whatever port number ICMP is going to be using, or whatever it is that you're trying to get across. And then it goes right back up to the router. Once it gets up to the router is going to take a look. First of all, the router is going to take any layer 2 information and say, throw it away. Doesn't care. It only cares about the network portion of the address. And it's going to say, okay, let me take a look at my routing table. Let me see where this destination network is going to. Oh yes, I see you're going to the 2.0 network. Okay, well, the 2.0, according to my routing table, I have to switch you over to that interface right there and send you out to the next router. So there is no ARP in between here. So the information gets sent to this middle router right over here. The middle router sees that destination network, right? Because in the packet, that's what it says. Hey, this is the destination network. And this is where it came from, the source IP address, and this is where it wants to go to. Okay, layer 3 information says, oh, okay, well, according to my routing table, I see that 2.0 network, or that 2.1 address, it's in that, I got to take you out the F00. So I'm going to switch you over to the F00, to that doorway, if you will, and send you out that way. But I don't know the MAC address of the PC that belongs to, the end node that belongs to. So what do I need to do as the router? Or I'm going to go ahead and send an ARP request. So I can go ahead and get, because now we're going back down to Ethernet. So we need that MAC address. We have the source, the IP address where it came from, the source network. We know the destination network. We have our source MAC address, which is our F00 on the router right there. But we need the destination MAC address, or that particular end node that we're pinging. So that ARP request needs to happen. So when that ARP request happens, it comes back up, says, hey, that's me, completes a frame, then the information goes back down. Once that gets complete, then it goes right back up and goes to the other side. Now your book will explain it in extreme detail, all right? I believe it's 26 or 36 steps or something like that, which you should read. You should read. But what you're going to get on the test is questions about ARP. And what are the type of questions that they're going to ask you? Let's take this scenario, for example. Let's take these 2 routers so I don't have to move back and forth. Let's take these 2 routers right here with these 2 PCs right here. If I were to ask you a question, if PC1 wants to ping PC2, what will be the destination layer 2 address? Well, the destination, if it's from PC1 to PC2, the destination layer 2 address will be the gateway address of that particular router, the F00, because layer 2 or ARP stays within its own segment. So The source layer 2 address will be the PC. The destination layer 2 address will be the router's gateway. The source IP address will be, or the source network, let's say, will be this network, or the source IP address will be the PC. And the destination IP address is wherever you're pinging on this side. So this is the line of questioning that they're going to ask you when it comes to ARP. They may show you, let's say, a little figure, maybe with an envelope going that way or something like that, right? They say, hey, and it's all Ethernet. It may not be serial. If it's Ethernet, you have ARP, ARP, and ARP. 3 ARPs. So you have 3 different frames being created. So if this, instead of being a serial media, it will be a twisted pair or fiber and Ethernet, that means an ARP will have to go across. Will have to happen. So then they will tell you, well, if it's going from here to here, and it's Ethernet, what will be your destination layer 2 address? Or destination MAC address, let's say. It will be that interface right there. If it's Ethernet, and I keep saying that because I know I have a serial cable, I'm saying this will be Ethernet. Meaning you'll have a crossover UTP or whatever cable, Ethernet. If this would be Ethernet. All right? This will be the destination layer 2 address. This will be the source layer 2 address. So this is the kind of things you need to look out for in the test. So the routing process is the same thing over and over and over again. Once it knows, and you have your ARP cache, right? Your computer has it. If you do an ARP -A, you're going to see your ARP cache. A router keeps an ARP cache in the RAM, so it already knows where it's been. The switch has an ARP cache. Everybody has an ARP cache, and it keeps it for a certain period of time. As long as communication still occurs, that ARP cache won't erase unless you erase it deliberately. Now, even though it still has the ARP cache, the process at least will be one less. There will be no ARP, but it's still got to look at its routing table. When the packet reaches that router, or the frame, I should say, reaches that the router discards the layer 2 address, okay, because there's no ARP, it already knows, so no ARP happens. So it goes to the router. The router, all it cares about is saying, hey, you're coming from this network and you want to go to that network. Which way do I need to send you? Do I need to send you this way? Do I need to send you this way? Apparently it's not in your network because you wouldn't have gone to your router. You would have gone to your gateway. You wouldn't have sent it. The protocol wouldn't have sent you. IP would not have sent you to the gateway if it was local. So since it saw that it wasn't a local IP address, it sent you to the gateway. So then it's up to a router to look at its routing table to make a decision on which way to send you. Okay? That is the job of the router. And with that in mind, these are the lessons to come next, right? In this particular session. What type of routing am I going to use? Okay? Which we'll talk next. So you need to make a decision. Because this in IP version 4, you really need to pay attention to how things are getting sent from one point to the next. And are we creating ARP? And are our routing tables are being efficient? Are they efficient? Are they too big? Do we need to do route summarization manually? Whichever protocol that we're using. Are we building a hierarchy? So you don't need to know about everything. So when the path of the network gets created, because that's what the routers do based on the routing protocols, they create the logical path. Or are you going to create the logical path? So the routing process is going to be the same regardless the size of your network. Regardless. If it doesn't have an ARP entry, this is the first time you're sending information, or just there was no communication being sent, so the ARP table got erased, and you send an ARP first, and then it replies back with a MAC address of your gateway, and then it sends the information. The router still needs to look at his routing table to make a decision where to send you, and then the same thing happens on the other side. It could be 2 computers, 2,000, 2 million, 200 million. It doesn't matter. That process repeats itself over and over and over again. This is the reasons now we have neighbor discovery in IPv6. It's making things a lot easier to network with a lot more nodes that we have now. but you need to understand this routing process. In order to network, we need to know the source MAC address, which is ours, of course, the destination MAC address that's within our own segment, which is our gateway, right? If we're going outside our network, the destination IP address and the source IP address and the port number. If you're FTPing, if you're telnetting, if you're SSHing, if you're going on the internet, those destination port numbers. That's what I'm talking about. And that's going to be the line of questioning you're going to be asked on the test. So when you're going through this chapter in the book that I've always told you to look at for your certification, these exercises that they have in there is what you need to focus on. The understanding of ARP. And they'll give you several examples like this. If this will be a server, let's say, and that's a web server, this PC2 here, pretend it's a web server, and I want to ping this web server. I want to go to this website, let's say. I'm going to go to a web page. It will still do the ARP, give me back the MAC address. I will send it back up to you. You make a decision which way I need to go based on whatever type of routing I'm doing. Send it, because it looked at his routing table, send it out to the next router. That router will then switch it, look at his routing table and say, okay, it's down my fast Ethernet 00. First time I know this, so I'm going to send an ARP down. He's going to reply back, and I'm going to send it right back down to that particular one. So it doesn't really matter. The process stays the same, and that's what you need to understand. So with this web server, destination MAC address, source MAC address, destination IP address, source IP address, and it's a web server, port 80. That right there are the questions that you're going to get asked, or the line of questioning that you're going to get asked on your examination. That is what you need to look at. But not only in exams. When you're in a real world environment and you're trying to get to a destination network, we do our trace routes and see where the problem is happening and why is it happening. Do we have an entry for that particular network? Why did it drop at that point? Are we having a physical layer issue? So all these things come into mind. But definitely, understanding this process will help us in the future to troubleshoot, hey, where did the problem go wrong? Or how is my packet being, how is my packet traversing the network? How did I get over there from point A to point B? So that chapter on the routing process is important, but I broke it down to very simple steps, and that's what it is. If you want to read all 36 steps, you go for it. You go for it. The more knowledge you know, the better. But definitely, you want to go through the examples. Go through the examples, because their examples in that book are the examples that you're going to see, not verbatim, obviously, but is the examples that has the same concept that you're going to see in your exam. All right, ladies and gentlemen, that is your IP routing process. Now, we start learning, hey, how are we going to route? Okay, I'll see you in the next lesson.